Okay, so in this video, using the simple model you see in front of you here, I'm going to show you how to prove that the Earth must be orbiting around the Sun given those two times that you measured of when the star appeared in your tube, or when the star disappeared behind that thin string that you put in your tube. I'm going to show you how those times allow you to prove the Earth must be orbiting around the Sun. So first thing, this is the Earth, this is the Sun, and way over there is a distant star, maybe the one that you tracked in your tube. So here's the Earth, and that toothpick sticking out is your tube, just pointing up in the sky, measuring things. So first thing to get clear is what your clock is measuring, because remember, you use some timer in this experiment, which is either your phone or your watch or something, but all those clocks and things that we use on Earth are set to so-called solar time. And what that means is this: if you orient your tube right at the Sun, the Earth rotates, as we know, and when that Sun appears again in the tube, that means 24 hours has gone by. So if you measured, say, 12 noon, and the Earth started to rotate like this and went all the way around, when that tube is aligned with the Sun again, your clock or watch is going to read 12 noon again. That's just the way it's programmed. That's called solar time. Okay, so what I'm going to do is let's remove the Sun now. Just keep that in mind. Let's remove the Sun from the picture, because I understand when you're looking at your star, it wasn't during the day, the Sun wasn't there. Let's keep a little marker in place about where the Sun was. Not because the Sun has to be there, but because we know when this tube rotates and points to the Sun again, that's when 24 hours will have gone by on your phone's clock or your wall clock or your watch. Okay, so I hope you get that. Whenever the tube points again at where the Sun was supposed to be, that's 24 hours. So here's the way this goes. On evening 1, when you're measuring the star, you can see that the tube here is pointing at your star. So the tube is going to pass, the starlight's going to pass right into your tube, so it's going to leave the star, travel all the way across the galaxy, go right into your tube, disappear behind the thread, you mark that in time, and you're done. Okay, so what happens now is the Earth definitely is rotating, as we know, but it's also orbiting around the Sun. So it's going to do something like this. It's going to spin like this and orbit at the same time. And look, when you get here, the starlight is going to be in your tube again, because this tube is pointing at that star all the way over there. So the light, once again, is going to come all the way in from the star and go into your tube. That's going to be your second time. But what you have to realize about this now, and this is the whole key to the proof, is that the tube is pointing at the star. It is not pointing at the Sun. 24 hours has not gone by yet. What you have to do if you want 24 hours to go by again is you have to wait a bit more for the Earth to rotate a bit more to bang till it points towards the Sun again. Because remember, we said the premise at the beginning of the video, whenever this tube points at the Sun, that's when 24 hours has gone by, not before, not after. So it's when it points directly at the Sun. So that's the proof right there. The fact that the Earth starts here, rotates around and orbits, and you see the star pass in your tube before you see the Sun. Remember, star, Sun, star, Sun. And also, let me do it this way. Not quite 24 hours, 24 hours. Not quite 24 hours, 24 hours. Not quite 24 hours. So you should see that starlight a little bit less than 24 hours later from night to night. And that's the proof. The fact that you see that starlight coming in before you see the Sun, or 24 hours goes by, is the proof that the Earth is not just sitting here rotating, but it's also orbiting around the Sun. So there you go. Hope this model helps.